looking at the solubility product and then the common ion effect, the experiments of the solubility product, how we can use an experiment to determine the solubility product. So simply, the solubility product is the product of the molar concentrations of the ions of the ions of a sparingly soluble solute contained in a saturated solution of the sparingly soluble ionic compound. Each compound raised to the appropriate powers. This is not chemical kinetics, whereby we shall say that the experimenter determined the powers. So these powers are raised, and then the solubility product is determined at a given temperature. Then when you look at the common ion effect, for it to look at the precipitation of a sparingly soluble ionic compound from its saturated solution. As I have written up these definitions by adding a soluble compound containing a similar ion to the ions contained in the sparingly soluble compound. So when you look at these things are not difficult, so part B of the question is telling us to describe an experiment how we can find the solubility product of here we shall be looking at silver oxalate. So we can see the equation of solubility of the silver oxalate. So what we need to know that in these experiments we have to prepare a saturated solution. So after preparing a saturated solution, in that solution we determine the concentration of the individual ions. But basing on the equation, we can determine the concentration of one ion, and then it will be easy for us to determine the concentration of the other ion. So in the experiment, we can easily start by saying that we can say excess silver oxalate is dissolved in a given amount of water. Then, of course, this water must be distilled, and then the solution is the solution or the mixture is filtered, so obtaining a saturated solution. But before even, remember, you have to check that mixture. You shake it, then that's what will help us to make sure that the salt or the solute has dissolved until its maximum point. Maybe it has we have formed a saturated solution, so that the filtrate is a saturated solution. In that filtrate, then we pipette a known volume. Of that saturated filtrate that we have obtained. Then after pipetting a known volume, for example, I have the silver ions and then the oxalate ions. We know very well that in our practical chemistry, we use the potassium permanganate as the something that we can use to titrate against the oxalate ions. So they will oxidize the oxalate ions to give us carbon dioxide, and then the two electrons in that half cell equation. Then when we write the equation, the half cell equation for potassium permanganate, we combine the two equations, then we come out with the reaction. From that reaction, we can determine the concentration of, because we know the concentration of potassium permanganate that they have given us, so we can determine the concentration of the oxalate ions. Then, as we see in the equation, the concentration of the silver ions is twice the concentration of the oxalate ions, so we can come up with the concentration. Then we go to the solubility equation, whereby we know that the Kp is equal to the concentration of the silver ions raised to power 2 times the concentration of the oxalate ions, like that. So we come up with the equation like that. The equation, we can determine the concentration of the oxalate ions, and then we can also determine the concentration of the silver ions, and then we get the product, we get the Ksp. Then from there, the alternative experiment we can use, we prepare still a saturated solution, and then we determine the molar conductivity. This is now using the other conductometric method. So we determine the molar conductivity of the silver ions the molar conductivity at infinite dilation of the silver ions of the silver oxalate. So since we can get the molar conductivity of the silver ions and then the oxalate ions at infinity from the tables, then we add the two, then we get the molar conductivity of the silver oxalate at infinity dilation. Then the solubility of silver oxalate, which is the X, we let it to be maybe let the solubility equal to X. So we say that the solubility or the concentration of the silver oxide is equal to the electrolytic conductivity of the saturated solution. Remember, electrolytic conductivity K out of the molar conductivity at infinite dilution is equal to the solubility of the silver oxalate, which we have letters X, or the concentration, you can call it C. That's basically you can look at. This is the first part of the question. Members, like the videos, share the videos, make sure that the video reaches every person wherever that person is, so that he can make use of this video and get the best out of it.